Okay, so let's keep talking about resonance in what is delocalized and localized lone pairs. So I'm going to give you a couple more examples on that. Say that I have this molecule now. I'm going to draw aniline. Then I'm also going to draw pyridine. So let's do a little nitrogen here. Yeah, a little blurry, but it is there. Now, notice here that we have a lone pair in aniline. That lone pair is adjacent to double bonds, so that is the allylic pattern. And I could do resonance here. I could move those electrons over here. And since I am making a double bond there, I cannot expand the octet at this carbon, right? So I need to move this. And I'm going to draw now one resonance structure of aniline. And I can make several. I'm going to draw, for example, this one. Now, we'll have electrons here, and double bond here, double bond here. Because this nitrogen has 2 hydrogens here and 2 bonds, it's 4 bonds total, it will have a formal positive charge. So overall, I have a 0 charge. But now notice, the lone pair, what I'm saying is that this is an allylic lone pair, so it is delocalized. This one is on a nitrogen that is sp2 hybridized. But now we need to recognize that there is a pi bond between the nitrogen here and the carbon right here. And so that means that already my nitrogen is using a p unhybridized orbital in making that bond. And if this is sp2 hybridized, I'm just drawing this part. That is now making up a couple more bonds, right? But to carbon in the ring. But the point is that this nitrogen right here is already forming this double bond. That means that one of the bonds is now to this side to a carbon, and this is on an sp2 orbital perpendicular to where to the pi system, let's say. Now, this is where my lone pair is. So if you see here, that pi bond is like this, and my lone pair, notice, is on a dash, just like that. It's perpendicular. So, summarizing that, we're going to say this is localized because it is, the electrons are on an sp2 orbital. And that sp2 orbital is perpendicular to the pi system, to all of the perpendicular to the, say, all of the p orbitals in the pi system. So, system. These are localized. In other words, I cannot move that. And I'd be able to do resonance structure in aniline. Similar to that is another example of here, lone pair. This is pyrrole. And in pyrrole, we see lone pair adjacent to double bonds. So that is the allylic pattern. So here, this is involved in resonance. So this is a delocalized lone pair. So again, this is important to recognize patterns, and also when we have localized and delocalized lone pairs. In other words, localized will not be involved in resonance, like this example of pyridine. And the example here is aniline. This is a delocalized lone pair, meaning it is involved in resonance. We're going to continue doing more in another video.